Okay, so today I'm doing the 2002 hydrostatics question, part A. So first, before I even write anything on the page, I'm going to pick out what I need from the question. So as you can see, this question is kind of split into three parts. So I'm just going to read through it and see what they're about. So it reads, when placed in liquid A uniform solid cylinder floats upright with 2/5 of its axis immersed in the liquid. When placed in liquid B, the uniform solid cylinder floats upright with 4/7 of its axis immersed in the liquid. What fraction of the cylinder's axis is immersed when the cylinder floats upright in a uniform mixture of equal volumes of liquid A and liquid B? Okay, so the first part is mostly about liquid A, or is completely about liquid A, and then we've got liquid B, and then we've got a mixture, so I'm just going to call it M for mixture. So what do I need out of this question? Well, I've got a few figures. So I've got 2/5 for liquid A, 4/7 there. And another thing is that I have a uniform mixture of equal volumes of liquid A and B. Okay, so I want to figure out what type of question this is because there's different types of hydrostatics questions. And since it says floats 3 times in it, it's pretty apparent that this is going to be a floating question. And we have a little bit at the end about mixtures. So now I kind of have an idea of what formula or formulae I'm going to be using. So that's about it. Just one quick thing is that it's a uniform solid cylinder, so it's not hollow or anything like that. So that's good to know, but it's kind of irrelevant once we start doing the question. Okay, so now that we've gone through the question and know what we're about, let's get into it. So I'm going to put the question where I can see it. And keep referring to it all the time and start. Okay, so they haven't given us any diagrams, so I drew them roughly out. It's always a good idea to draw diagrams so you can visualize what's going on. Okay, so I've got my one for liquid A here, and we were told in the question that it was 2/5 of its axis immersed in liquid. So I have that represented here by the 2/5. And then we've got our liquid B. So it was 4/7 for liquid B according to the question. So that's and then we've got for the mixture liquid, we're not told how much, and that's what we have to find. So I call that F because it's supposed to be a fraction. Okay, so at the top of the page, I'm gonna have it where I can see it all the time. My formulas. So since we got from the question that this is a floating question, I'm going to use the formulas that I always use for floating. So my very first one is going to be upthrust. So for anyone that doesn't know, upthrust is basically, some people call it buoyancy as well. It's the upward force that a liquid or gas exerts on a body floating in it. So you can see that there. That's our upthrust. Okay, so our upthrust is equal to the density of the liquid multiplied by the volume displaced by the object multiplied by gravity. Okay, so the next formula we're going to use is what I call the floating formula, which is that upthrust is equal to weight. Okay, so just to explain that a little bit there, when upthrust is greater than weight, the object will rise until so that's our object here, until the upthrust is equal to the weight. So that's that there. And since we're using weight, we have a very handy formula on page 56 of our formula tables, which says weight is equal to density multiplied by volume multiplied by gravity, and we're going to use that there. Okay, so other formulas we're going to need for this, since there's a mixture involved in kind of the second part, let's say, of the question, I'm going to use the density of the mixture formula, which goes a little bit like this. So we've got the density of the first liquid involved in the mixture multiplied by the volume of the first liquid involved in the mixture, plus the density of the second liquid involved by the volume of the second liquid involved, and that's all over the volume of the first liquid plus the volume of the second liquid. Okay, so now that we have all our formulas sorted out, let's do a little bit of labeling up here since we have so many densities. So here I've got the density of liquid A, density of liquid B, and I've got a density of the mixture. So those are my 3 densities I'm going to use. Okay, so we've got a lot of formula going on. It's kind of getting a bit confusing. So let's figure out what's constant between our 3 scenarios here. So we can keep it as simple as possible. Okay, so I'm just going to write them up the corner where I can see them. Constants. So as always, gravity is always constant. And since the cylinder stays the same in each scenario, it's only the liquid changes, we can say that the density of the cylinder is going to be the same in each scenario. So I'm going to denote that density of the object. As well, the total volume of the cylinder is going to stay the same, so I'm going to call that the volume of the object. I'm just using rho there for density and V for volume. Okay, so where do we start? If I look at all this, I know in order to get F, I'll need to use the density of the mixture, because F is only relevant, like it's not relevant here and here, it's only relevant when the cylinder is interacting with the mixture. And if we're going to use U is equal to W here, we need the density of the mixture, and we'll see that working later on. So how do I find the density of the mixture? Right now we've got the density of A, the density of B, and the density of the object to work with. To find the density of the mixture, but that is way too many unknowns, so I'm going to eliminate the density of A and the density of B by putting them in terms of our constant, which is the density of the object. Okay, so let's start off with liquid A, and we're going to use our floating formula, which is that upthrust is equal to weight. So that is the density of liquid A multiplied by the volume displaced, which is, from our question, is 2/5 the total volume of the object. Okay, so how I found this is that we're told that 2/5 of its axis is submerged, and the great thing about cylinders is that we've got a uniform cross-sectional area. So the fraction of the axis submerged is equal to the fraction of the volume of the cylinder submerged, and because the volume of water displaced is equal to the volume of the object submerged, that's why we can put 2/5 the volume of the object there. So that's really handy for volume displaced. And of course, they're all multiplied by G. So that's all equal to our weight of the object, which we said was density O, volume O, multiplied by gravity. So I equate that. And what I got was that density A is equal to 5/2 density O, because these all cancel out. Okay, so that's that. Similarly, for liquid B, I'm going to do the exact same thing. I've got the density of B multiplied by 4/7. The total volume of the object, which I got from the question, was 4/7. By gravity is equal to the density of the object by the volume of the object by gravity, which is our weight there. So when I did that out, I got the density of B was equal to 7/4, the density of the object. Now, I know some people will get to this line here, not really sure what's going on, and be tempted to put this equal to this, because as you can see, the weights are the same. But the reason we don't do that is that we're using our mixture formula later on, and we want the density of A and the density of B to have the same unknown, an unknown that is relevant to how the mixture interacts with the cylinder. Now, because the mixture is a new liquid with a new density, the density of the A and the density of the B aren't directly relevant to how this liquid will act on that object, whereas the density of the object, because it's the same object, still is. So we need everything in terms of the density of the object. So now we've found our values for the density of liquid A and density of liquid B, we can sort out the density of our mixture. Okay, so we've got a uniform constant for density. What about these volumes? So let's go back to our question. It says that we've got a uniform mixture of equal volumes. So I can say that the volume of liquid A involved in the mixture is equal to the volume of liquid B in the mixture, and that's directly from the question. So say if I call VA VL, or say that VA is equal to some quantity VL, that means VB is equal to some quantity VL. So now I've only got one unknown. Now for this, I'll show you when we put it into the equation. So we've got, I'm going to input our value for PA here, or rho A, sorry, 5/2 density of the object, so that's multiplied by VA, which we call VL, plus rho B, which is density of volume, or liquid B, multiplied by volume B, which we said was equal to VL. So that's all over VL plus VL, or 2VL. So I would take a few lines to figure this out, but because I've had it done already, because you will make mistakes if you try to do that straight out, because I have it done, I know that our density of the mixture is equal to 17 rho O over 8. Okay, so now we are ready to finally input this into our U is equal to W for the mixture. So I'm just going to put an M here so we know we're on this bit. So it's U is equal to W to find our fraction submerged. Okay, so as we said, upthrust is equal to the density of the liquid, which we found here. So I'm going to go 17 rho O over 8 multiplied by the volume displaced. So as we said earlier, we can use the fraction of the axis multiplied by the volume of the object, which is equal to the volume displaced, multiplied by gravity, is equal to our weight of our object, which we said was rho O V O G. Okay, so now when we can get that out, we get that F is equal to 8 over 17. So that answers our question for the fraction of the axis. So I like to put a little box around it, just so for ease of correction. Yeah, so that's that done.